Hello, my name is Daniel Fernandez. I'm the owner of scienceinhydroponics.com, and today we're going to be talking about EC and pH changes in drain to waste hydroponics. So what does this mean? We're going to be discussing what happens with the pH and EC of solutions as they interact with plants, and how these values change with time, and which values are normal, which ones are not, and how you can actually manage these changes. So let's discuss first the basics of a drain to waste system. So you'll usually have a container that has some media, and then you'll have your plant roots here, then you'll have your plant here, and you will feed something here, which we will call the feed, which is a solution. You will feed a given volume, which I'm going to call V0, with a given EC and a given pH. Then we're going to get something out, which we usually call the runoff, which also has a given volume, a given EC, and a given pH. So usually V1 will be way smaller than V0 because the media will retain a lot of the liquid. But how will the EC and pH change? That's our question. So let's remember what the EC depends on. So if you saw my video on conductivity, you might remember that the EC depends on which ions we have in solution and how many. So any change in the EC will be either a change in which ions we have, in how many ions we have, or in how much water we have. So how many ions per volume of water we have. And the pH depends on only one thing, which is how much hydronium you have in solution. Which of course this depends on a ton of things, but this is to make it simpler. So let's start by thinking about what can happen here as the solution goes through the media. So first, we have that the plant can uptake water. So the plant can take in water from the nutrient solution. Second, we have that the plant can uptake ions. Third, we have that the plant can excrete some substances, so the plant can actually add things into the solution. And four, the feed might actually dissolve ions in the media. So things can actually accumulate here or can be present there due to the media. So either the media can carry them from the beginning, like coco coir can carry significant amounts of, say, sodium chloride or potassium chloride, or they can just accumulate by feeding. So whenever you feed, water evaporates or water is uptaken by the plant, and therefore you have salts left here. And then when you feed again, these will redissolve and will contribute to change the EC or the pH. So now let's discuss how these four things affect the pH and the EC. For this, we're just going to do a little table here where we're just going to talk about EC and pH. How do these things affect EC and pH? So what happens when the plant uptakes water? You are removing water from the solution, but you still have ions left, so the conductivity will go up because you're removing water. So there are more ions per volume of water. What happens when the plant uptakes ions? Well, if the plant uptakes ions, then the EC goes down because you have less ions. If the plant excretes substances, it's adding things into the solution, and these are mostly ionic substances, so the EC will go up. And if the feed dissolves ions that were in the media, then these were ions that were not in the feed and that are now in the feed, so the EC will go up. So as you can see, we have three things that contribute to increasing the EC of a solution, and only one thing that is expected to decrease it. So in the end, what happens is that the EC of a solution will tend to increase as it goes through a drain to waste system. But what is important to understand is that this does not mean that the plant is not actually eating, which is a common mistake. When you have when you graph the uptake of a plant through time, you will see that plants uptake ions, and the uptake of ions increases with time. So as a plant gets bigger, the amount of ions that it will take out of solution will increase with time. But what happens with water? Water will grow a lot more and a lot faster. So what happens is that 1 will become significantly bigger than 2 as time goes on. So as a plant becomes bigger and bigger and bigger, the EC will tend to increase more and more and more because of this phenomenon. Because the plant is uptaking way more water than ions. And this happens because ions are required for plant growth, and growth only happens in the edges, on the edges of the plant, like where it grows along its edges. But water is necessary to evaporate. So the plant is constantly evaporating water and transporting water to do this. And as the surface area of the plant grows, as it has more leaves, its water demand will increase more. So while the demand for ions increases with time as the plant has more growing edges, the demand for water increases way more as the plant surface area increases way faster than its growing edges. So this is the reason why you see this sort of thing. It doesn't mean that the plant is not eating. As a matter of fact, it means that it's eating way, way more. It's just absorbing way more water than it absorbs ions, and this causes the EC to increase. Now, as you irrigate more and more with fertilizer, 4 also becomes a great contributor because ions from previous irrigations will redissolve and will tend to increase the EC. So overall, the EC will increase as a function of time. Now, in terms of pH, what will happen with the pH? So when you have a plant uptaking water, this does not change the pH because you're just making the solution, all ions in the solution, more concentrated, all of them. When the plant uptakes ions, then the pH can either decrease if it uptakes cations, or it can increase if it uptakes mainly anions. So these are ions with a positive charge or ions with a negative charge. Now let's explain this a little bit more. So for example, when you have a plant in veg or in early bloom, when we're talking about flowering plants, or even when we're talking about just leafy greens, what you will see is that there is going to be nitrate absorbed mainly. This is going to be one of the main ions that will be absorbed by the plant, and these will tend to increase the pH. Now, when we have some plants going to bloom, for example, plants that are heavy users of potassium, then we can see the pH actually go down because of this strong absorption of potassium. But there are other phenomena that can cause the pH to change. For example, if you have a lot of ammonium will cause absorption, which will cause the pH to go down. And when you have chloride, the pH will also go down because chloride is absorbed very aggressively. And this can also happen, will go up. Chloride is an anion, so the pH will go up when it's absorbed. And then you have things like citrate, which is an anion, which will also cause the pH to go up aggressively. And this is one of the reasons why citrate and citric acid are, despite the fact that chemically they would seem like a very good buffer, biologically they are uptaken aggressively by plants and microorganisms. So the pH will actually tend to increase if you use citrate or citric acid. This is why many people who use vinegar or citric acid to lower pH pretty quickly realize that it doesn't stick. It doesn't tend to have any staying power. And this is because plants will uptake it, and this will tend to increase the pH, completely defeating the purpose of adding it to lower the pH in the first place. Now, what happens with the plants when plants excrete substances? When plants excrete substances, then it's the same thing. If they excrete cations, the pH can go down, and if they excrete anions, the pH can go up. However, the dynamics here, the plant will tend to excrete more anions than it does cations, mainly because the things that the plant excretes will tend to be things like citrate. They will tend to be organic weak bases, so the pH will tend to increase when the plant does this. As the plant grows, it will also tend to do this more aggressively, but that depends a lot on the plant species. And then the ions that we dissolve in the media, these come from the solution, so the effect will depend on what the media is. So this is actually will depend a lot on what the media is and what the media tends to accumulate. So this can have a different effect. However, this effect will be the most important from the four, sorry. So plants uptaking ions will be the most dramatic factor in changing the pH, unless the media is very strongly changing the pH. For example, you can have things like peat moss aggressively decreasing the pH because it decomposes, and the decomposition of peat moss can generate a lot of organic acids that can actually cause the pH to go down very aggressively. So this can be a factor to consider, but the plant uptake is going to be the main determinant for media like rock wool, for example, or even cocoa that's being properly treated. So now let's talk a little bit about what's normal, so that you can get a sense of how things are supposed to go. So in general, plants uptake more water, more water than nutrients. So since plants uptake more water than nutrients, this means that the EC will tend to go up, and this is just normal. And then salts accumulate in the media, and this means that the EC will also tend to go up. So these two things are the basic reason why the EC of the media will tend to go, the EC of the runoff and the media will tend to go up as a function of time. Now, what happens with the pH? The pH normally goes up. So if nothing else, if you are feeding a strong hydroponic solution that contains a lot of nitrate, then the normal thing is for the pH to go up, and this is when nitrate is dominant. And this happens even for some flowering plants during flower. This happens if the solution has enough nitrate. Plants will uptake this very aggressively, and this will be the dominant force in the entire thing. So this is what happens. Now, in some cases, pH can go down. pH can go down, and this is mainly due to flower in some plants. So basically, a very strong K absorption, or the solution basically uses lower N, and the plant absorbs enough potassium to push the pH force to the other side. But generally, pH goes up is a fair assumption. If you are feeding a formulation in flower that contains a lot of potassium, then this can also happen during late flower, depending on the plant species. Now, the important thing is, how do we manage these things? So how do we ensure that our plants are doing what they're supposed to do? How do we manage the EC if it increases too much? How do we manage changes in the pH? So the first thing is to measure. So always measure these things. Always measure EC1 and pH1 and EC0 and pH0. Because if you don't measure, you won't have any idea. So then what's the point? So always make sure you measure. And the first thing to do if the EC increases too aggressively, like you can allow the EC to increase somewhat. It's normal for the EC to increase, and you can allow it to a certain point depending on which plants you are growing. But if it increases too much, then the first defense is to increase V1 and V0. This means just increase your irrigation volumes so that you can normalize the media. The more you feed in an irrigation, the better chances that all the salts that are here will dissolve, and you will be able to normalize the media a little bit more. So feeding more is always a good strategy to start to counter this. Of course, it's a waste of fertilizer in a setup like this, so it has its limits. You don't want to waste a lot of fertilizer. Now, the other thing you can do, if, for example, if the pH changes, is to change pH 0 within the range of 5.5 to 6.5. Like you don't want to get outside of this range as a general rule. Some plant species do allow you to feed like 4.5, for example. Lettuce can be fed 4.5 under some circumstances with no problem, but it depends a lot on which plants you are growing. So the idea is that if the pH goes higher, then you will feed closer to 5.5, and if it goes down, you will feed closer to 6.5. So you just try to counterbalance and try to feed in the other direction. Then the other defense we have is to change the nitrate to ammonium ratio. Plants will uptake ammonium very aggressively, and this will tend to lower the pH. So if the pH is increasing, then you can increase the amount of ammonium relative to nitrate, and if it is decreasing, then you can go the other way around. This can be a quite effective defense against pH changes, but it is not without consequences. Some plants do not like this ratio to be changed, and usually when you change it as a way to compensate for the pH, it can have bad consequences. So sometimes just lowering the nitrate is enough. You don't need to increase the ammonium, but then that can also come at the expense of yields. So a lot of these control measures that I'm gonna discuss now are at the expense of yields. So this is one of them. Like if you choose to do this, your plants can actually be better, the pH of the media can behave better, the pH of the runoff, but then you might have issues with the plants. Now, another potential way to deal with this is to increase the concentration of buffers. So we have a couple of chemical buffers. You know, if you saw my video, my last video on pH, you will know that in hydroponics we have this buffer that is based on phosphoric acid species, and we also have this buffer that is based on carbonic acid species. And this can be done by adding MKP and potassium carbonate. So if you add these two things, you can increase the concentration of these buffers. But of course, increasing phosphate does not come at no cost. Some plants will not like this. If you add too much phosphorus, you can also cause problems with the absorption of zinc and copper. So you want to be careful with this, but this can actually be an effective strategy, especially if your water is not tap water, if it doesn't contain any carbonates at all. This can actually be an effective strategy to decrease the extent of pH changes. Now there's also, if your EC is too high, you can also reduce EC0. So just reduce the EC of your feed. And this can actually work quite well. Because I mean, if the EC is increasing too aggressively, then it might cause heavy damage to the plants. So reducing EC0 can be a solution. Some people will actually just do, for example, tap water irrigation or an irrigation with pH adjusted water that contains no nutrients once every while to just flush the media from the accumulation of salts, which can be a valid growing strategy, although it might not give you the highest yields. Usually the best yields are obtained when all these things are controlled such that the runoff never reaches these extremes, but they are managed. The EC is managed so that these extremes are never reached. Okay, so these are some of the basics of EC and pH changes in drain to waste. I hope I covered most of the basics of how this works, and I hope you can find some useful advice within this video. Please remember to like and subscribe. I'll see you on the next video, and bye-bye.